Hello everyone, welcome to this live migration production workloads from Apache Mesos PaaS to Kubernetes session.
My name is Maria.
And my name is Gufran.
And we work for Nokia. And Nokia is a producer of network equipment and software and services for our communication service providers.
Yes, and as you all know that Nokia, driven by its award-winning Bell Labs, Nokia is a leader in the development and deployment of 5G networks. So 5G, is going to be the core of connecting people, connecting world in the future, or it's already happening actually. So we're still connecting people.
Yes, we do.
Yeah.
Okay.
This is the story. So in today's session, what actually we're going to talk about? We're going to talk about a migration story, our migration journey from Mesos-based PaaS to Kubernetes. So just imagine, as you can see already also on the slide, there is a GIF which is showing that two trains moving side by side. First one, definitely the Mesos, something that we started working on in the beginning of the project. So Mesos is running all the workloads, providing all the services and so on. And then Kubernetes comes in and sharing the same platform resources, right, moving side by side. And then the workloads are migrated from one platform to one train to the another one without interrupting the existing services, without interrupting the users. So a seamless migration on a shared platform. We're going to talk about this today in this session, our journey of Mesos PaaS to Kubernetes.
Right.
Yeah.
Right. So a little about our project. What was it all about? So the Mesos is only the orchestrator, or Kubernetes later on. On top of the orchestrator, what we have is a big data analytics platform. We provide a set of services for end users who bring network specific data into our platform. They store this data. They use several tools that the platform provides for analytics. They use a BI tool for presentations. So this is a never-stopping process of different data sources coming in, hundreds of users, hundreds of data analysts working on the clock to provide analytics for our customers. And on the screen, you can see the high-level architecture of this platform. You can recognize probably the logos of several open source components. So we concentrated on using open source. So this is Apache Mesos. We are not using Mesosphere. Right, so the goal was to switch, keep the platform as it is, keep our users working as they were, but in the lower level, move slowly from Mesos
seamlessly, without
seamlessly, yes, from Mesos to Kubernetes as orchestrator.
Yeah, and just to mention a few things, so this is a big data platform. So we had around five production instances across 4 different continents and thousands of users. This platform has been also used to do things like such as MDT, minimization of drive tests, predictive analysis, and process, terabytes of network element data, performance data, and so on, and do some analysis, store in the database, and visualize it. There were also many different successful even customer cases as well, where this platform has been used actually for doing those things. I think we started this project around 2015 or 2014 timeframe. Yes. But by 2018, we noticed that Kubernetes was getting a lot of industry attention. Industry leaders were starting to use it. It was starting to become industry's darling, and we also wanted to adopt it for many different reasons. And Kubernetes was becoming the center of a growing community, quickly reaching production level maturity, and there were more and more features being promised to Kubernetes. And while we actually noticed at the same time that Mesos was getting less and less work done, less and less features coming to Mesos, but Kubernetes was getting more and more people working on it. And also one of the reasons could be that Mesos was at that time, productized, or there was an enterprise version, and there were less and less people working in Mesos. But also from Kubernetes side, there were things such as daemon sets, deployments, deploying your application with health charts.
Huge amount of benefits we wanted.
Benefits that we saw, although there were some lackings on the Apache Spark side, that you couldn't run Spark natively in Kubernetes, managing these local persistent volumes, etc. But the benefits were much, much more than some of those things.
The drawbacks.
Yeah, and since we did a spike where we identified how we would like to migrate, so those were not really any issue for us, because we were planning to run both of the platforms side by side, seamlessly migrate components one by one in a release-driven manner, prioritized, and also there were rollbacks and features like since they're sharing the same platform services, developers were also being able to use those things. So we started moving to Kubernetes.
Right.
A little bit about Mesos overview.
A little bit about Mesos, exactly. So we can take a look at the high-level architecture. As you can see on the left side of the screen, we have the basic highly available cluster, 3 master nodes, 2 in standby, 1 acting as leader, zookeeper in the backend keeping the leadership on, and the worker nodes who actually host the workloads. So how the workloads get there? All the worker nodes provide their availability and the resource situation to the master. The master hosts the application definitions through this application model. And when the application, also called framework in Mesos world, is ready to launch a job, a task, it uses a schedule. So selecting the available node based on the available resources, the schedule launches an executor, and the executor hosts the tasks.
Yeah.
And these tasks are actually the application. If we take, for example, Spark, Apache Spark as an example, so Apache Spark as a framework doesn't do anything. When it's ready to process data through Mesos master, it selects the appropriate worker or workers and launches the executors who actually do the data analysis.
And on the other hand, for example, we could mention the Marathon framework that we have been using. It's one of the popular frameworks for Mesos to run, containers. It doesn't necessarily have to be container. You can run some tasks or even some scripts using it. So in Mesos, the scheduling works that you've got different frameworks registered to Mesos. They're getting, resources from the resource pool from Mesos and working based on this, dynamic resource fairness scheduling policy. So that's the Mesos overview.
Mm-hmm.
And if we look at this Kubernetes overview here, these pictures, as you can see, basically the same. They're doing almost the same things, of course. Both of them are sharing ancestry of Google Borg. But also in Kubernetes, you can see in the architecture, there's like 3 master nodes, or, there is even like elections going on and leader, and you've got this API server, scheduler, control manager, all this stuff. And the worker nodes, you can see kubelet, which is basically, making sure that the containers are running in a pod, kubeproxy, taking care of the networking, etc. But in the Mesos side, the Mesos slave or Mesos agent actually process that was taking care of similar things. So they are very much similar in terms of, how they are working. The scheduling also, you can see here on the right, basically similar to Mesos. Then this is the picture together, like the marriage of Mesos and Kubernetes.
Yes, that is true. So the way we selected to go is to host them together, not on so 2 clusters working together in the same pool of resources. We didn't want to have separate clusters, separate deployments. What we wanted to do is to keep the existing production platforms up and running and basically hook Kubernetes into this setup. They would share resources on the control plane and also on the workload management. They would be completely invisible to the end users, and the applications that were already working on Mesos will continue to do so, and the new applications or the migrated applications would be hosted on the Kubernetes cluster running in exactly the same place. So as you can see, master nodes, same 3 for Mesos and Kubernetes, and worker nodes, all of them sharing both Mesos and Kubernetes workloads. There is a small gray box in the worker nodes, which represents our magical script, which is called kubelet.
Kubelet wrapper, yeah.
Kubelet wrapper, yes. So we will talk more about the kubelet wrapper. But this was just one more Mesos application that was running in the backend. No user interface, but it was taking care that the Kubernetes workers were up and running and were able to consume some resources from the host and hence host the loads.
Yes, so basically when you run the kubelet wrapper on Marathon, boom, you've got this Kubernetes cluster.
Yes.
And the interesting thing is that they are not fighting with each other's resources. As you can see here in this kubelet wrapper in Marathon, in this slide, you can see how a kubelet wrapper is running in Marathon. So basically in Marathon, you do not, your application doesn't necessarily need to have a container. You can just run any scripts or tasks. There is Mesos containers as well. So we can see here a kubelet wrapper running in Marathon, and with this Marathon job, what we can do is we can control how many nodes from the cluster will be, sharing
Also
resources and
Kubernetes
also become Kubernetes nodes.
Yes.
And also we can control the resources, so how much CPUs and MEMS they will have, and with this kubelet system reserved parameters, then Kubernetes will not be confused with Mesos used resources, and so basically all the resources that are used by Mesos is seen to Kubernetes as system reserved, and then there will not be any oversubscription or any issues with the limitations of resources or fighting with the resources. And Mesos also on the other side is able to see how much resources Kubernetes is using from particular node and so on. You can actually even run kubelet with no resources assigned at all. So basically that is that could be used for pod eviction and stuff like that. And so even a node is running kubelet doesn't necessarily mean that it has resources. We can control those from this. So this is really a very nice magical script. Okay, it looks very simple, but we try to follow this KISS principle: keep it simple, stupid. Systems work best when they're kept simple, and we also are a bit lazy. We try to do less and gain a little bit more. But of course, all these are coming from Spike, which we started, when we started thinking to move to Kubernetes. But now that we have seen the picture of a kubelet wrapper in Marathon, Maria would like to say something how we actually package it.
Yeah, so how it all worked. All the platform major components were actually packaged into a VM image, and this VM image was transported to the target cloud where the platform was supposed to be deployed on.
Yes.
And this gave us the possibility to deploy fairly on any cloud, in customer premises or in our internal Nokia cloud, which was the actual environment where we had the production clusters running.
Yes.
So from the list on the screen, you can see all the components. You can see Mesos, you can see Marathon, Kubernetes, and so on. So these are the open source applications that we would deploy as part of the platform. And as part on the little box on the right, you can see that as part of the Kubernetes role or the Kubernetes folder is where we have the wrapper.
So basically, we're using Packer. Basically, we're just creating the images and all the necessary binaries and scripts that we would like to, let's say, carry offline in certain offline cases, which was actually one of our major requirements as well, that we would be able to deploy it offline. And so you basically, back up everything in your laptop or in a USB stick and deploy it in a customer premise or in an offline environment case where you don't have access to internet. So packaging the VM image, now that we have it in the VM image, we launch it from Marathon.
Yes. So we are ready to deploy with the image. And
and this you can see here is just some app definition in Marathon. Even the kubelet wrapper itself is also deployed in a metadata-driven deployment way, which also we had identified during our spike. Sorry, during a spike that we can leverage the existing way of deployment, so that it's much easier for the developer teams to migrate their applications. So as you can see here, this app type Helm. So in app.yaml, the developers would put app type Helm after creating their Helm chart, of course, for their application, and then our command line tool will just identify it as an Helm application, and it will just install with Helm. And if they didn't provide it, which means that they didn't need to make any changes, applications that are running in Mesos, they didn't need to make any changes. So the existing way was also working, and we also were able to gradually move to Kubernetes, based on priorities and release cycles and so on. So on the bottom side, you can see there is an example of CouchDB, which don't have this app time Helm. So this was actually a Marathon application. So that's how it's been deployed. And although all these things look fairly simple, definitely there are many other things underneath, but these are...
we're simplifying for the presentation also,
simplifying
right?
For the presentation, yes. And here is a picture of little things, what we have learned from this project, just sharing. Also, although there are a lot more than this.
A lot more, yes. Little and big things. So we kind of found in practice, and while implementing the side-by-side deployment of both clusters, using them side-by-side and troubleshooting, of course, as usual, you have issues on the way. So we found out that part of the winning kind of conditions come from the correct strategy. So, and the points in achieving the best strategy is to study first. So we did a spike, as Gufran mentioned, implementing the side-by-side deployment, hosting workloads, and making sure that the resource consumption was controllable for both clusters. Following the KEYS principle, keep it simple, right?
Yes.
And achieve more with less. So we don't need more clusters,
complex,
a complex system. Yes, what we need is to keep running as we did, but introduce this parallel cluster and a parallel work on deployment.
Other thing also here, we can see we're clearly saving resources. We're clearly saving some different complexities. Like if you would like to have another Kubernetes cluster deployed, with dedicated hosts and stuff like this, then
backup and restore
you
features.
need even more resources, and it gets even more complicated and so on.
So hooking the new cluster into an existing platform, we took advantage of the logging management, of the metrics management,
the telemetry system were accessible even when we didn't move them to Kubernetes. So they were being shared between the both platforms.
Yes, and since we use the same overlay network, all the logs, every container that was running there was collected by the, let's call it, old system. So everything was working as expected, with a slight difference that some applications were hosted on Kubernetes.
Yes, and one immediate measure is because Kubernetes manages the daemon sets, very smoothly. It's very nice, and also the deployment for the Helm applications. The deployment was very nice. Although in the beginning, I remember there was this Helm 2, and there were some issues with CRDRs.
Yes.
Management, yes, and but with this Helm 3, it's been resolved. So Method-driven deployment way was really helpful for us. Kubernetes and Mesos both sharing the same resource pools, no extra resources needed. And of course, we need to dimension our cluster properly, including the system resources, because if you're not dimensioning the cluster properly, you may have issues. Let's say, the application is requiring certain resource that none of your nodes or worker nodes actually providing, and it can happen even for Spark jobs as well.
Yes,
which is,
and one thing that now that you mentioned the dimensioning topic is very important, because it did happen to us, at least in the beginning, where development teams were getting used to the fact that if they are going to deploy the application not on Mesos anymore, but on Kubernetes, they would need to tune the resource assigned to Kubernetes through the kubelet wrapper. So the magical script was not so magical anymore if you didn't provide the right information to it.
Exactly, yes.
Yes, so there was some effort needed from everybody to kind of keep in sync between resource consumption and migrated applications.
Yes. So basically, we also didn't have any duplicates within the shared platform. So we were sharing, for example, the telemetry systems, and even the etcd, same etcd was being shared.
Yes.
So we were also saving resources from that point of view.
Yes.
That you don't necessarily need to have multiple services.
One for each.
Dedicated for each. Yeah. So that's basically it. There are a lot more. Feel free to ping us. We will definitely share. And here is a bonus, just a picture of some of the tools that we have used and loved.
Yes.
Yeah, and Maria has and myself has mentioned during this session already some of these, that probably you're already using, and Kubernetes is there bigger because that's the industry darling and our new baby.
Exactly.
Yeah, or it's not new anymore, but yeah. Hi, so this is the end of our session. Thank you very much for joining.
And we are ready for your questions. We have had some already in the chat. We'll have time for more, so please write your questions.
Meanwhile, we can maybe share what questions were asked. One of the questions were, what is Marathon? Is it an app? Yes, it's an app actually. Second one was, how did we handle the layer 4 load balancing, where the applications from Mesos side accessible from the Kubernetes side? Yes, that was actually the original goal, to be able to share, similar all the resources and all the services within both of the platforms to be shared. So, for example, telemetry systems, monitoring and alerting, all these things, they were being shared before even being moved to Kubernetes. And while we gradually moved from one to another, we were able to make use of the existing services.
Yeah, and maybe it's good to mention, and we didn't say it in the presentation, that the Nginx was one and only for both clusters. So
there is also a question here.
Yeah.
Would you like to read it out?
Yeah, sure. So Kashif is asking, how will the whole system behave in case of resource congestion?
Very good question.
Yes.
Yeah.
Do you want to go on, Gufran?
Yeah. So, as you know that during the presentation we have mentioned, like Mesos is able to know how much resources Kubernetes is using, and Kubernetes also knows what is its limit. And also we have got this telemetry systems, monitoring and alerting, where we were watching at certain thresholds we'll get alerts in terms of CPU or memory congestion. So definitely we were getting alerts before issues happening, and our SREs were taking care of those. But yeah, so Mesos and Kubernetes, both the clusters, even though they were sharing resources from the same resource pool from the node, they were not getting in fight with each other. And before even there is another question.
Yeah. How do you decide pods request limits for CPU and memory? Do you use the vertical pod autoscaler, or do you have a smarter algorithm? So I think none, basically, of those options. I can answer this one. What we had predefined resource requests and limits for those applications that were migrated to Kubernetes from Mesos. And we have estimated, based on our experience in production and performance tests, how much resource they would maximum be allowed to consume and how much they need to start. So we would assign kind of a fixed set of requests and limits for those applications.
Is there any more questions?
Not.
But these are really very nice questions, and the migration is actually whoever have used some other clusters before Kubernetes, they would have a migration story, and probably there are many different stories. People are following different approaches. Yes. For our cases, we also wanted to save resources. We couldn't just go have new set of resources in a new cloud account and deploy the Kubernetes cluster separately over there and then migrate. That would be very costly for us.
Yes.
But this was really nice because we were just not really wasting any resources.
Right.
How long time do we have?
Conflicts for running Mesos and Kubernetes master processes on same nodes?
No, we don't have. We had those predefined. All the host ports that we had, actually, they were identified, and any other ports, with the overlay networks, we have got this for containers, unique IPs. So yeah, they are not conflicting with the ports.
Yeah, but basically we took care of defining the ports and specifying the ports carefully.
Yes.
To avoid the conflicts.
Yeah.
What platform did you use on-premise? If you refer for platform like the cloud, the hosting
Customer
cloud.
Deployment?
No, on-premise.
On-premise. Yeah.
Yes. So on-premise we had OpenStack. So this platform of ours was running in Nokia premises, and we have an OpenStack cloud.
Yeah, Nokia has, I think it's already known that one of the largest on-prem clouds provided to the internal developers and so on. So we were using that, and it's built on top of OpenStack.
Yes. There is one more question. Have you thought of running Kubernetes on top of Mesos and not beside it?
Nice question.
Like a Mesos framework? Yes.
Yeah.
We did. And we decided not to go for that.
Yes.
And basically why? Because we wanted to in the end, we wanted to get rid of Mesos altogether. Want to go this layer over layer
And side by side is actually then, basically they're independent of each other, even though they're sharing resources. When you have like one is deployed on top of the other, then if you have issue with the one of them, then you have issue with the other one,
Yes.
Any other questions? We are running out of time. Counting 3 minutes.
Yeah, but basically this Kubernetes on top of Mesos was the Mesosphere approach, and they provided this service as part of the Mesosphere, which we didn't use.
Yeah, we didn't use the enterprise version of Mesos, so we were using the open source versions, and basically using as much as, or was it over 95% of the components were open source.
Yes.
Of course, we were, tweaking, changing, adding stuff. I think everybody's doing that based on your requirements and necessities, but yeah. Any other questions? Thank you very much for these questions. These are very nice questions. And was there another one actually?
No. Okay, so we can end the broadcast whenever you wish.
Yeah. Yeah. If there are no more questions, I think we can end the broadcast. And thank you very much for joining, and hope you enjoy the KubeCon.
Yes.
The virtual one, first ever.
Yes, thank you. We have enjoyed.
Yeah.